students, welcome back. Let's see the examples of the Bresenhams line algorithm. So in the previous video I explained what are the steps that you have to be taken to implement the Bresenhams line algorithm. So now see the example. So here what they are saying, draw a line from 2010 and to 3018 using Bresenhams line algorithm. So let me start. So the first thing is, the first step is let's start and endpoints have to be accepted. The x1, y1 is nothing but 20 and 10. And whereas x2, y2 are 30, 18. So these are the start points and these are the end points. So we need to find out the middle floating points from starting to ending so that the line segment can be formed. Okay. So in the step 2, you need to be find out what is the dx value and the dy value, the difference between the x and the x2 minus x1 and the y2 minus y1 you need to be find. So now let's take dx is equal to x2 minus x1, that is 30 minus 20, you will get 10. And dy is equal to y2 minus y1 is equal to, so what is the y2? 18 minus 10, you will get 8. So here in the Bresenhams algorithm, you have to take the decision parameter. The decision parameter have to be calculated. Based on the decision parameter, you can say whether the upside pixel is accepted or the downward pixel is accepted. Okay, so that you have to be that is based on the decision parameter. So whenever the decision parameter is less than 0, then closest pixel is below the true line. And whereas the decision parameter is, let me just recall you that if decision parameter is less than 0, then SI is smaller. That you have to be accepted. Means it is below true line. It present below true line. What is that? The pixel is present below the true line. That pixel you need to be accepted. Suppose if the decision parameter is greater than or equal to 0, that then you have to declare that TI is smaller. A TI is nothing but the pixel that is closest to above the true line. Above true line. So just remember these 2 points. Okay. So now let's start. So first you need to find out the initial decision parameter. Initial decision parameter. Why I am calling it as an initial decision parameter? Because for every succeeding values, the decision parameter will be also increasing or decreasing based on the value. Okay, based on the values that we are taking. So starting decision parameter here is, the formula is 2 dy minus dx. So what is dy here? 8. And what is the dx? 10. Okay, you will get 6. So the initial decision parameter is 6. And also just calculate the 2 dy. Also just calculate 2 dy. 2 dy is nothing but 16. And 2 dy minus 2 dx is equal to minus 4. So just substitute the values here. The dy value and dx value you need to substitute and you will get this. Okay, so d naught is 6. Okay, now starting the initial iterations. Let's take di, it's a decision parameter, and xi plus 1 and yi plus 1. So incremented, the next value, incremented value that you to be written. Okay, so first iteration 0. What is the initial decision parameter? Initial is 6. So we are doing the problem of Bresenhams line algorithm. So you have to use those formulas. And xi plus 1, yi plus 1. So what are the xi and yi value? Okay, that is the initial values. The initial values of x1, y1 are 20, 11. And the final endpoints are x2, y2. That is the endpoints. You can take it as endpoints. Okay, just endpoints. Endpoints are 30, 18. So in between the values you need to be find out. So starting 20, 11. So you just add 1 incremented. So that is a 21, 11 plus 1. Okay, so here 10, not 11. Okay, 10 plus 1, 11. Okay, so that is xn is equal to, you're just doing xn is equal to xi plus 1 and yn is equal to yi plus 1. So when decision parameter is greater than 0, whenever the decision parameter is greater than 0, so you have to increment the x value and you have to increment the y value. Suppose when decision parameter is less than 0, you have to increment the x value and write as it is y value. No need to increment. So this is the formulas. So here decision parameter is greater than 0. So I just incremented the x value 20 plus 1 and yn 10 plus 1. Now let me take the next iteration 1. Now what is the decision parameter here? So whenever the I is equal to 1, okay, for I is equal to 1, let me calculate di plus 1. So di plus 1 means di plus 2 dy minus 2 dx. So what is di? That is d0. d0 at starting. d0, that is the 6 plus what is 2 dy? 16. And what is minus 2 dx? 2 dy minus 2 dx is nothing but minus 4. Directly you can write minus 4. 6 minus 4, 2. So now the decision parameter is 2. Don't be confused. I'm incrementing the di plus 1. di plus 1, di plus 1, I have to be incremented. So this is also greater than 0. Greater than 0 means just increment the value. 21 becomes 22, 11 becomes 12. Now 2. Now let's calculate the decision parameter. di plus 1. So this time di is 1. d1 plus 2 dy minus 2 dx. So what is the d1 here? The d1 is 2. Okay, 2 dy minus 2 dx is minus 4. You will get minus 2. So whenever the decision parameter is less than 0, so here you got the decision parameter is less than 0. So whenever it is less than 0, you have to increment only the x coordinate, not the y coordinate. So just increment the x coordinate 23 and don't increment the y coordinate. Just write as it is. Why I have written like this? Because here di is less than 0. Okay. Sorry, it's greater. di is less than 0. So whenever it is less than 0, you have to increment only x, not y. Now 3. So like that you need to be calculate right. So I'm just writing all the numbers. So 10. 25 comma 14, 5, 26 comma 15, 6, 27 comma 16, 7, minus 2, 28 comma 16. So whenever it is less than 0, you don't increment the y value, right, as it is. 8, 14, 39 comma 17 and 9. So 10, that is 30 comma 18. So you got the final parameters. So you reach the final parameters. So the starting parameters are 20 comma 1, the x and y coordinates, and the final coordinates are 30 comma 18. So in between, these are all the different pixels. So based on these pixels, you need to be draw a straight line. So this is the Bresenhams line algorithm. Thank you.